Hello, good afternoon, sir. It's Sir Gerald again. So for another lesson or another topic here in at Zero. So for today, we will be talking about another concept under geometry, which we call distance and midpoints. So for this part of the lecture, actually, we will be talking about how to get the distance and the midpoints of points or two different points. So these concepts are actually useful when it comes to geometry since we will be dealing a lot with uh, with a lot of measurement and something like that. So measurements, getting something is something. Okay. So in that we'll be diving into first distance. So when we talk about distance, distance is actually we will be talking about the distance between 2 points. This is similar to our understanding or our lesson last week regarding distance and displacement on our primer on analytical geometry. So in that, when we talk about distance between points, we will be talking about distance between ordered pairs x1, y1, and ordered pair x2, y2. So that is the main difference between this computation because last time we only get the vertical displacement in distance, which is the distance between the x's. And we also discuss how to get the vertical distance that is will be the distance between y1 and y2. So for today, we will be talking about more on a singular measurement wherein we will be taking the distance between the 2 points itself. So in that, if we have here coordinate plane, say this one with the y-axis here and y-axis, okay, and we have here our x-axis, okay. So if we are to take into account this coordinate plane and say you have here your first ordered pair, say we have here x1, y1. And we also have another ordered pair, say we have here x2, y2. When we talk about distance between 2 points, we actually will be measuring the distance between these points in such a way that we will be getting the shortest, will be getting the shortest distance between these 2 points. That by shortest distance, we will be getting this distance. So how do we compute for this distance? Actually, by thinking of our past discussion regarding horizontal distance and vertical distance, we can actually do this using that. So if we are to get the if we are to get say if we draw some lines here or line segments, use another color. If we have this line and also this line, we actually have what we call this. portion wherein we can actually visualize that we have here the vertical and the horizontal distance of our points. By vertical and horizontal distance, as you may have remembered, if we are to get the horizontal distance, say this distance, this line below, this is actually just equal to our the difference between our x's in the ordered pair. Meaning to say, we can actually measure this line by simply getting the difference, which is x2 minus x1. Right. So another thing here is we can actually also get the distance between the vertical distance of our points, wherein we just need to get the difference between y2 minus y1. So that is our differences. We have here the vertical line, y1 minus y, or y2 minus y1, and we have a horizontal line, which is x2 minus x1. And as you may have noticed here, this actually formed what we call a right triangle. Okay? So, trace lang natin, ano? So, we have here a right, ganda, triangle. Mhm. Hindi siya masyadong sumakto. But anyway, we have here our right triangle. So, approximate nyo na lang na sakto yung gawa ko. Ano? But anyway, if we are to consider this as a right triangle, we all know that if we have our right angle there in that corner, or we have there an angle that measures 90 degrees, we all know that this will be our longest side, or what we call our hypotenuse. So, it is the same with our dilemma here. We need to get that measurement. And that measurement is actually equal to the longest line or longest line segment of this triangle. And we can actually also say that this will be our A, or which is equal to our x1 minus x2 minus x1. And we can also say that this will be our side B, which is equal to our y2 minus y1. And all and as you may have remembered on your earlier days of geometry, there is actually a formula on which we can compute this C. And if you can remember, that is actually what we call the Pythagorean theorem. By Pythagorean theorem, actually, we only say that if uh, we have a right triangle, the longest side, which is C, or the square of the longest side, is just equal to the sum of the squares of the shorter sides, which is A square, or our A, plus B square. So that is our Pythagorean theorem. And in this scenario, C is just equal to the distance between our 2 points. So that will be that line C here. And A is just equal to x2 minus x1, and B is equal to y2 minus y1. So if we are to substitute them, this will be actually equal to C is equal to uh, x2 minus x1, and we will square that, plus y2 minus y1, and we will square that. Okay? So, what we need is a measurement of C, not C squared. So in that, we'll be just getting the square root of x squared minus x1 squared plus y2 minus y1 square, which is actually equal to our distance. The distance between x1 and x2 and x1 y1 and x2 y2. So just write that x2 minus x1 square plus y2 minus y1 square. So in here, actually, we already have what we call our distance formula, which is given by this formula. Okay? So for our distance formula is equal to the square root of the square of the vertical distances and the square of the horizontal distances. Distance. Okay? In that, let's have here some examples. So we have here our points A and B, where point A is located at 0, 2, and point B is located at negative 3, 2. So in that, let's first determine, or let's first determine what are we dealing with here. So first, let's identify the parts of our problem. So for the parts of our problem, we have here actually our x1, y1, and also we have here x2, y2. So what do we do next? We just simply plug in those values on our formula, which is this one. Okay. So what we need here is we'll have here distance between AB will be equal to, let's first get the x's, so that we have here negative 3 minus 0 square plus we'll have here 2 and minus 2 square. So solving that, we will have here, this will be negative 3 square. So negative 3 times negative 3, that will be 9, plus 2 minus 2, that will be 0, and 0 square will be 0. So that will be equal to square root of 9, which will be equal to 3. So the distance between points A and point B will be 3. Okay? So that will be our answer for that. Alright. So you can try on solving different problems here by simply, let's say, let's add here another point, say point C, which is located at, say, 4, ay, 4 and negative 4. Try to compute the distance between uh, AC. Try to compute for the distance between BC, and that's okay. So you do this example, and I will just plug in here the answers. Feel free to pause the video so you can solve this yourself. Okay, so for the distance between points A and C, we just plug in our answers here. So we have here 0, 2, and 4, negative 4. So let's deal with the x's first. So we'll have there 4, 4 minus 0 square. That will be our x2. This will be our x1. plus the square of negative 4 minus 2. That will be negative 4 minus 2 square. So we'll be left here with 16 because that will be 4. 4 square is 16 plus this will be negative 6. Negative 6 square will be 36. So we'll be left with square root of 52. Please check kung tama ba yung ano ko. And ultimately, I think there is no simplification for square root of 52. Try 16, 25. So that's it. We have here square root of 52. So for distance of point B to point C, okay, that will be equal to taking B as our first and C as our second. That will be, let's deal with the x's first. So we have here 4 minus negative 3, okay, raised to 2 plus we have here 2, 4, negative 4 minus 2 square. So we'll have here 7 square, that will be 49. 49 plus, we have here 36. So we have here 49 plus 36 will be 85. 5. So we have here square root of 85. Also have no lower term. So we have here the square root of 35 is the distance between points B and point C. So we will be ending it here for now. So then we'll be preparing another video for the midpoints. Bye bye.
A few moments later.
Hello, Les. So in that, actually, I decided to continue on with the video or the discussion. So our next point or next part of our lesson is actually what we call the midpoint. So by a midpoint, it is actually a point that is located halfway between two points. So in that, if you consider, let's say, x1 and say y1 and x2 and y2, we can actually, if we draw a line segment between those two, that is the line segment, we can actually locate one point. By one point, we can locate another point here, which is uh, uh, which is actually in between x1 and x2. So to get that point, say that uh, x question mark and y question mark, we can actually use the process, or we can actually determine that point by simply getting the averages between the x's and the y's of our points. For example, in that midpoint, say if we actually get the midpoint, which is m, it is actually equal to an ordered pair, which is equal to the sum of x1 plus x2, and we divide it by 2, and we'll have there the sum of y1 plus y2, and with divide it by 2. Why do we need to divide it by 2? Since we are getting the midpoint, we will be getting the average, and by average, we only are getting the average of two objects or two measurements, meaning we only divide by 2. So that is how we get midpoints. So for example, if we are to use our earlier example, say we'll just lasso this. Let's use that. So if we, for example, we need to get the midpoint. Ay, if we are to get the midpoint of AB, midpoint of BC, and midpoint of AC, we can actually use this formula. So in that, for the midpoints of AB, we will have here, so we have here x1, x2, we just add that. So we have there 0 plus -3 over 2. Then we have here ry. So we have 2 plus 2 over 2. So that will be equal to -3. We have here -3 over 2. And we have here 2 plus 2 is 4 divided by 2. We will have there 2. So the ordered pair -3 over 2 is actually the midpoint between the points A and B. So let's try BC. By BC, same process. We just need to add 3 plus 4 and divide it by 2. Okay. And we have here 2 and 4. We just need to add that. So we have 2 plus -4 divided by 2. So we will have here -3 plus 4, that will be -1. -1 divided by 2 is simply -1 half. Okay, so we have here 2 plus -4, that will be -2. -2 divided by 2, that will be -1. So -1 half, -1 is the midpoints between -3, 2 and 4, -4. So for AC, same. So we'll have here 0 plus 4 over 2. And we'll have here 2 plus -4 over 2. Then we will have here 0 plus 4 is 4. 4 divided by 2 is 2. And we will have 2 minus -4, that will be -2. -2 divided by 2, that will be -1. So 2, -1 will be the midpoint of points A and C. So it's that easy. Okay? So you just need to get the averages of the x and y components of your ordered pair, and therefore you have their midpoints. Okay. In relation to that, next meeting we will be dividing the line segments between 2 points. So see you next time, or see you next discussion. But for the next meeting, we will have another quiz regarding our discussions from distance up to the midpoint, and that quiz will be posted on Friday by 4 p.m. on our Edmodo group or Edmodo class. Again, bye.